Welcome to the second session of polynomial. In first session, we have studied how to find the value of a polynomial for a particular value of variable. In second framework, we begin with concept zero of a polynomial. Zero of the polynomial is the value of the variable that makes the polynomial equal to zero. That means, if a is the zero of the polynomial px, then pa should be zero. That's the concept. We will study this concept with the help of some examples. This question. Verify whether the following are zero of the polynomial. That means verify x is equal to minus 1 by 3 zero of px. As the value of the polynomial for a particular value of variable. Here we substitute x with minus 1 by 3 and do the necessary arithmetic and check whether p minus 1 by 3 is 0. If p minus 1 by 3 is 0, then minus 1 by 3 is 0 of px. Here it is arithmetic. P minus 1 by 3 is equal to 3 into, in order to x, we substitute minus 1 by 3 plus 1. Then we will get the answer is 0. So, x is equal to minus 1 by 3 is 0 of px. Take the second one. Px is equal to 5x minus 5. We have to check x is equal to 4 by 5 is 0 of px. Substitute x with 4 by 5 and do the arithmetic. We will get the answer as 4 minus 5. It is not equal to 0. Since px is not equal to 0, that is p 4 by 5 is not equal to 0. 4 by 5, x is equal to 4 by 5 is not the 0 of px. We will look some more problems. Verify whether the following are zeros of polynomial indicated against them. That means verify whether minus 1 and 2 are 0 of px. As in the previous example, what we have to do is substitute x with minus 1 and 2 and do the necessary arithmetic. Check whether px is p minus 1 is equal to 0 and p2 is equal to 0. Then p minus 1 and p2 are 0. First we will take x is equal to minus 1. That is, substitute x with minus 1 and do the arithmetic. We will get the answer is 0. So p minus 1 is 0. Since p minus 1 is 0, x is equal to minus 1 is the 0 of px. Take second one. As in the first one, while we do the arithmetic, we will get p2 is equal to 0. Since p2 is equal to 0, x is equal to 2 is 0 of px. Take the second one. We can see that while we substitute x with 0, we will get p0 is equal to 0. So x is equal to 0 is 0 of px. That is here. p0 is 0. So x is equal to 0 is 0 of px. Third one. Px is equal to lx plus m. We have to check x is equal to minus m by l is 0 of px. Substitute x with minus m by l and do the arithmetic. We can see that p minus m by l is equal to 0. Since p minus m by l is equal to 0, x is equal to minus m by l is equal to 0 of px. And this one fourth one is left for you. Before we go to the remainder theorem, let us take a brief introduction about division of integers. That is, the remainder theorem is related to the division. First we take the division of two integers, 39 and 5. This 39 is called dividend and 5 is called the divisor. While we divide 39 by 5, we will get the remainder 4. You have studied in earlier classes the relation between divisor, dividend, quotient and remainder. Dividend is equal to divisor into quotient plus remainder. This relation is used for test of divisibility. Our concentration is about division of polynomials. Before we divide two polynomials, what we have to do is arrange the given expression into descending order of degree of terms. That is, first we will write term with higher degree, then term with lower degree. That's all. So here we take two expressions, 2x square plus x plus 1 and x plus 1. And this term is called divisor, dividend, and x plus 1 is called the divisor. We can look how can we divide x plus 1. How can we divide 2x square plus x plus 1 by x plus 1? Take the first term of the dividend, that is 2x square. Divide it with the first term of the divisor, that is x. While we divide 2x square by x, we will get 2x. This is the first term of the quotient. Divide first term of the dividend by first term of the divisor. Then you will get the first term of the quotient. Multiply this term, this first term of this quotient. This is the first term, 2x. Every term of the divisor. 2x into x, 2x square. Plus 2x into 1, 2x. Okay. Then do the subtraction. Then these two terms will cancel. This plus 2x will become minus 2x. Then, so while we subtract it, we will get minus x. Brought down the remaining terms. This term, minus x plus 1 is the new dividend. Divide the first term, that is minus x, by first term of the divisor. Let's divide the first term of the dividend by first term of the divisor. That is minus x by x. Then you will get the answer as minus 1. This is the second term of the quotient, minus 1. As in the last step, multiply this second term, minus 1, with every term of the divisor. Minus 1 into x, minus x. Minus 1 into plus 1, minus 1. Do the subtraction. While we do the subtraction, these two terms get cancel. This minus will become plus. So plus 1 plus 1, 2. This 2 is the remainder. Relation is same. This one. This is the division of polynomials. In this case, while we divide two integers, if the remainder is 0, then this divisor is called one of the factor of the dividend. Am I right? If the remainder turns 0, if the remainder becomes 0, then this divisor is called one of the factor of the dividend. The same case is true for division of polynomials. If the remainder turns 0, then this one, divisor, the expression in the divisor is the factor of this one, this dividend. So we just concentrate only about the remainder. We have to check the remainder. If the remainder is 0, this expression is factor of 1. I have already told you that just concentrate only about factorization of polynomials. Factorization means splitting of the given expression into simpler term. Then only we can evaluate it very fast. Okay? We just concentrate only about the remainder. Next we will look at the remainder theorem. The remainder theorem states that if we divide a polynomial px by a linear polynomial gx, linear polynomial means polynomial with degree 1, x minus a. The remainder is equal to pa. That is, if we divide a polynomial px by a linear polynomial x minus a, the remainder is pa. This a is 0 of this polynomial, 0 of gx, that is a. Let us take an example, that is divide, and we have to find the remainder when x cube plus 3x square plus 3x plus 1, that is a cubic polynomial divided by x minus 1 by 2. Here we concentrate only about division by linear polynomial, not higher degree polynomials. 0 of this, that is, this is px. Px is equal to s cube plus 3x square plus 3x plus 1, and gx is equal to x minus 1 by 2. 0 of this polynomial is 1 by 2. So remainder is p of 1 by 2. This P of 1 by 2 can be calculated by substituting x by 1 by 2 and do the necessary arithmetic. Then we will get the answer as 27 by 8. So this is the remainder. This is very easy one. Then we can take another example. What's the remainder when 1 plus x plus x square plus etc. plus x raised to 100 is divided by x minus 1? Sometimes the question may be get confused, but it is very simple. This polynomial is taken as px and this is gx. 0 of dx 1. So remainder is p1. Substitute x by 1. We will get 1. This one is there. This one 1, 1, 1, 1, 1. 1 raised to 100. That is also 1. How many terms are there? This x, this is 100 terms and plus 1. That's 101 term. That's very important. While we add 1 into 101 times, we will get the answer 101. So this is the remainder. Another example. Find the remainder when 3x cube minus 2x square minus x plus 2 divided by x. Gx is x. 0 of dx is 0. 0 is the 0 of gx. Gx is x. So remainder is p0. While we substitute x for with 0, we will get the answer as. And what's the 0 of a constant polynomial? If dx is equal to or qx is equal to 6, what's the 0 of the constant polynomial? No, there is no 0 for constant polynomial. Sometimes it may be asked in MC. There is no 0 for a constant polynomial. Now let us take a brief look at the introduction part of remainder theorem. That is, while we divide 2x square plus x plus 1, why? With x plus 1, the remainder is 2. Just we can check it. What's the 0 of x plus 1? Minus 1. The remainder is obtained by substituting 0 of this polynomial with x here. So, px is this one. 2 into minus 1 whole square. 2 minus 1. Substitute x by minus 1. Plus 1. So these two terms get cancelled. So you will get the remainder as. Is it right? So the remainder theorem says that px, gx are two polynomials. Provided gx is a linear polynomial, then remainder obtained by dividing this polynomial with the gx is p of a. A is the 0 of this polynomial. I have already told you that one more thing. When this remainder turns 0, this polynomial, this is dx, is called factor of this. This is factor theorem. Simple concept. That is, when this remainder turns 0, this divisor is called one of the factor of the dividend. Next we will do factor theorem. Factor theorem. If a is the 0 of the polynomial, then x minus a is factor of pa and vice versa. That means if we divide polynomial px with x minus a, the remainder is pa. If pa is 0, that is pa 0 means remainder is 0. That is the remainder theorem we have studied is that pa represents the remainder while we divide px by gx. So pa is equal to 0 means the remainder is 0. Then x minus a is called factor of px. That's I have already told in the last session, previous session. That is, we can look at some example. Determine which of the following polynomials has x plus 1 as a factor. That is, why we divide this polynomial by this polynomial, check whether the remainder is 0. If the remainder is 0, then x plus 1 is the factor of this polynomial. So we can take this polynomial as px. The remainder obtained by dividing this polynomial with this polynomial is p1. That is, 0 of this polynomial is minus 1. So p minus 1 is equal to minus 1 whole cube. substitute x with minus 1 and do the necessary arithmetic, we will get the answer as sum. So x plus 1 is a factor of this one. Okay, once again I will repeat. Take this polynomial as px and x plus 1 as gx. While we divide px by gx, the remainder is 0 of gx. 0 of gx is minus 1. So we have to check p minus 1 is 0. If p minus 1 is equal to 0, then this polynomial, this one, this linear polynomial is factor of this one. Okay, px, 0 of gx is minus 1, substitute p minus 1. When we do the arithmetic, we will get that p minus 1 is equal to 0, so gx is equal to x plus 1 is a factor of x. Take this second example, x raised to 4 plus s cube plus x square plus x plus 1. Similarly, we have to do p minus 1. When we do p minus 1, we will get the answer as 1. It is not equal to 0. So, gx is equal to x plus 1. This linear polynomial is not the factor of this polynomial. Next problem. Use factor theorem to determine whether gx is a factor of px. First question, gx is x plus 1. Px is 2x cube plus x square minus 2x minus 1. We have to check whether gx is factor of px. If gx is factor of px, then 0 of gx, that is 1, p1 should be 0. That is, px is 2x cube plus x square minus 2x minus 1 and gx is x plus 1. 0 of gx is minus 1. So, p minus 1 is equal to, substitute x with minus 1 and do the necessary arithmetic, we will get the answer as 0. So, since p minus 1 is equal to 0, this dx is a factor of px. P minus 1 is the remainder. Remainder is 0, then dx is the factor of px. The next question. Here px is s cube plus 3x square plus 3x plus 1 and dx is x plus 2. We have to find the remainder while we divide px by gx. The remainder is p minus 2. Minus 2 is 0 of gx. That is, dx is x plus 2. Dx is this one. 0 of dx is minus 2. So, p minus 2 is minus 1. It is not 0. So, since p minus 2 is the remainder obtained by dividing px with gx. P minus 2 not equal to 0, dx is not a factor of px. Next question. Find the value of k if x minus 1 is factor of px. The first question, px is s square plus ex plus k. We have to find the value of k here. Second question, 2x square plus kx plus root 2. We have to find the value of k here. That is, if x minus 1 is factor of px, the remainder obtained by dividing px with x minus 1 is 0. The remainder that we obtained while dividing px with x minus 1 is p1. This one is 0 of x minus 1. And substitute the value of x with 1 and equate it to 0. That is the remainder is 0. Equate it to 1. We can find the value of k. Okay. That is, since x minus 1 is factor of px, p1 is equal to 0. This p1 is the remainder that we obtain by dividing x square plus x plus k x minus 1. Substitute the value of x with 1. This is square. This is square. Sorry, square. And equate it to 0 and solve for k. Then we will get k is equal to minus 2. Similarly, for the second question, we have to find value of k by equating it to 0. That is p1. p1 represents a remainder that we obtain by dividing this expression with x minus 1. p1 is 0. That is, x minus 1 is factor. Since x minus 1 is factor of px, p1 is 0. Then solve for k. We will get k is equal to root 2 minus 1. Next, we will go through the Subject factorization of polynomial. Factorization means rearrange the given polynomial as the linked list of smaller systems. So we can do this evaluation more quickly. We have already studied in earlier classes that factorization of some algebraic expressions. That is, we have studied for a second degree equation. General form of the second degree equation is ax squared plus bx plus c. In order to factorize it, we have to find two numbers L and M such that L plus M is equal to b, that is coefficient of x, and L into M is equal to a into c, that is coefficient of x square into constant. So first we adopt this method. Take this example. 12x square minus 7x plus 1. So we have to find two numbers L and M such that L plus M is equal to coefficient of x. Actually it is minus 7, so but I take it as 7. And product of the coefficient of x square and constant term. That is 12 into 1 as L into M. So we have to find two numbers L and M. Condition is L plus M is equal to 7 and L into M is equal to 12. So in order to do this type of problem, we adopt a simple method. First we have to find prime factors of 12 and 1. That is prime factors of coefficient of x square and constant. The prime factors of coefficient of x square here 12 is 2, 2, 3. And prime factor of constant term, that is 1 is 1. From these prime factors, we have to find a middle term either by adding or subtracting or multiplying these prime factors. Here we obtain 7 as from 2 to 3, 2 into 2 plus 3. Am I right? 3 plus 4, that is 7. Product as 4 into 3. So we have find two numbers L and M. We can take L as 4 or M is 3. 3 plus 4 is 7 and 3 into 4 is 12. 12 is coefficient of product of coefficient of x square and the constant term. Okay. So now we can write it as 12x square minus, we have to split this middle term, 3x plus 4x plus 1. We just concentrate about this on middle term. Then we remove this bracket, we will get it as 12x square minus 3x minus 4x plus 1. Rearrange these terms, and from these two terms we take a common 4x into, while we take 4x as common, this time 12x square becomes 3x minus 1 minus this one. We put a bracket here, 3x minus 1. Why we take the negative as common, we will take 3x minus 1. Again, we group the common term. Then we will get 4x minus 1 into 3x minus 1. And I think you have studied this in earlier classes. Second question, 2x square plus 7x plus 3. Here we have to find two numbers L and M such that L plus M is 7, L into M is 2 into 3, that is 6. So first we have to find prime factors of 2 and 3. Prime factors of 2 into 2 and 1. Here 3 and 1. From these prime factors we have to find this one 7 and 6. So 2 and 3 we have to find. Our prime factors are, prime numbers are 1, 2, 3. So 7 is obtained as 2 into 3 plus 1. Am I right? 6 plus 1. Then L into M. Yet we can take L as 6 and M as 1. L into M. 6 into 1. 2 into 3, 6. So L and M are 6 and 1. Here 2x square plus 6x plus x plus 1. We can split the middle term 7x as 6x plus 1. 6x plus 1. So here we split the middle term as 3x minus plus 4x. Then, like in the previous questions, we take the common term and we will get the answer as 2x plus 1 into x plus 3. The splitting the middle term method is applicable to quadratic polynomial, that is polynomial with degree 2. If the degree is 3, that is cubic polynomial or polynomial with a higher degree, splitting the middle term is not applicable. So first we take a cubic polynomial. How to factorize a cubic polynomial? Here the polynomial is x cube minus 2x square minus x plus 2. In this method, first we will take the prime factors of this constant term. The prime factors of the constant terms are 2, 1, minus 2, minus 1. 4 factors are there. Then we will find the value of this expression for these prime factors. That is, we have to find p minus 1, p minus 2, p2, p1, p2 and check whether the answer is 0. This is a trial method. First we take p2. While we substitute x with 2 and do the necessary arithmetic, we will get the answer is 0. This is a trial method. Sometimes you may take it as 1. Then the answer will not be 0. Then you will take p2. So here I take p2. Answer is 0. Then x minus 2 is a factor of p2. That we have studied in earlier section. If p2 is 0, x minus 2 is the factor. That is why we divide px with x minus 2. The remainder is 0. That's the meaning. Okay. If we divide px with x minus 2, the remainder is 0. That's the meaning of p2 is 0. So you will get one factor for this expression. Next, what we have to do, it is an easy method to divide this expression with x minus 2. Then we are confident that while we divide this expression with x minus 2, the remainder should be 0. That is, x minus 2 is factor of this expression. So we divide x cube minus 2x square minus x plus 2 with x minus 2. I have already told you that how to divide a polynomial with another polynomial, linear polynomial. Then you will get the answer as coefficient as x square minus 1. Remainder should be 0. Then dx is equal to x square minus 1 into x minus 2. Then using the identity a square minus b square is equal to a minus b into a plus b, we can write it as x square minus 1 is x plus 1 into x minus 1. X minus 1 is this one. Or we can use this method also. First we substitute 2, then we substitute 1. Then while we substitute 1, you will get the answer as 0. Then x minus 1 is one factor. Then substitute minus 1. If you substitute minus 1, you will get the answer also 0. Then x plus 1 is a factor. Then minus 2. While we substitute x for minus 2, you will not get the answer. So x plus 2 is not the factor. Other three are the factors. You can do in that way also. Next question, x cube minus 3x square minus 9x minus 5. I have already told you that you have to find first you have to find the factors of the prime factors of 5. Prime factors of 5 are 5, 1, minus 1, minus 1. Then by trial method, you substitute. First you substitute 5. Then you substitute 1. Then you substitute minus x with minus 1. Then you will get the answer. Here I adopt this division method. First you substitute minus 1, you will get the answer 0. Then x plus 1 minus 1. X plus 1 is a factor. Then what I here is I divide this expression with the x plus 1. Then we will get this as coefficient. Then using splitting the middle term method, I can write it as x square minus 4x minus 5 as x plus 1 into x minus 1. Or you can do this method also, substituting the value of x.